Hi everyone, this is Mr. Rob, and today I'm going to show you how to add vectors but the graphical way. This differs from the analytical way in the way that we are not going to be using numbers or calculations to solve the addition of vectors. In this case, we're going to do a graph or a drawing to calculate the approximate vector or addition of vectors or resultant vector. Now, I want to start by showing you this protractor. This is the name of this, a protractor, and you are going to see that we have several numbers here. We have 0, 10, 20, 30, 40. So we have here until 90 degrees. This measures degrees, and we have here 180. And I have on this particular one, I start in 0 and then I go all the way to 180. So it goes in the opposite way. I here have a ruler. I have another ruler here on the bottom. So let me show you how to use it. Do you see this cross? Well, it has this, mine in particular has a hole, and I'm going to use that as my reference. So let's start this up and let's do a problem. Okay, the problem that we will be solving is the same one that we did analytically, and first we need some data. So let's find the data that we have. Here I'm going to write the data, and it's basically I have two vectors, vector 1, and vector 2. Vector 1, so this is the data. Vector 1 is going to be 200 newtons, and those 200 newtons are on the first quadrant, and we have an angle of 60 degrees. On the other one, number 2, we will have 120 newtons. This is the magnitude, which has a number and a unit, and an angle of negative 45, but remember that we said that we were going to take 315 degrees. So we're going to get those, and I'm going to show you how to solve it. So what do we want? We want the resultant vector. We don't know it, and the direction of the resultant vector, we don't know it either. So that's what we want. The first thing we'll do is I'm going to change colors here, and I'm going to draw a Cartesian plane. So here we go. Let's start this up. I'm going to draw here a line with my ruler. There you go. And here, to start using this one, do you see I have 3 points here that I want to use. I have here the 0, here the 0 or 180 on both sides, and a center point. So I'm going to just click there or put a point there, and I'm going to draw here in 90 degrees, another point. So you see I have a point here and there. Basically what I'm going to do is I'm going to draw a perpendicular line through this. So I got myself a Cartesian plane, and I have here X and Y. Now I have that. I'm going to draw the first vector. I'm going to use blue for the first vector. So here we go. The first vector is 200. We can do newtons. We can use either inches. In this case, you see the inches on this ruler is 1, 2. So this is better to use inches because they're bigger. If I would have used centimeters, here it goes, it will be too small and the error will be more. Now, I want to mention that this method is less accurate than the analytical one. So let's start on. Okay, so do I need first 200? No. First I need the direction to start drawing. So I'm going to put myself here in the center. There you go. And now that I'm in the center there, I'm going to point to measure 60 degrees. So I will start from the x positive axis. So I'll go 0, 1, 2, 3, 3, 3. Here it is in the inner side. So there you go. I have 60 degrees there. And now I'm going to use my ruler to start to draw a line of 2 inches passing through the center. 2 inches. Here's my 2 inches over here. You may see it. And I'm going to draw a line. There you go. So this is vector 1, which is going to be 200 newtons, and I'm going to have an angle of 60 degrees. Now that's just the first one. It's not an addition, it's nothing else. And then I'm going to do the following. I'm going to draw a Cartesian plane on the last point that I just used. So I'm going to draw a Cartesian reference here, and here we go. I'm going to make get a parallel line here. I can really draw it in a better way, right? But basically this is it, or I can do it like this. This is a better way. I'm going to put myself here, 0, 0, and I'm aligning this 3 points in the bottom with my 90-degree angle and the point of the arrow. So basically, there you go. It's here, 90 degrees. And here's my point. So these points, I'm going to use them to make that line there. There you go. So I got it there. And the other one, if I wanted to do this, right, get a longer one, you see, could have this one, and basically 2 points will make this Cartesian plane. So I have that. Now what do? I'm going to change colors, and instead of a blue, I'm going to use a red one. Yes, here's a red one. Vector 2 is 120, but again, I'm going to do first the 315. So I'm going to start here. So I'll go 90, 180, 270, and then the 315. Or the same thing is negative 45. So I will get the negative 45 over here. There you go. I have this 3 points aligned, have a 90 degrees aligned. So I'm going to go here from 0, now on the outside here, 45 degrees, which will be the same as 180 plus 90. So we will have 180 plus 90, 270 here. And then 270 to 315, we need 280, 90, 315. Okay, so 1, 2, 3. We will have 315. So we are here again. So I'm going to draw now from the last point to the point I put here, and oh, this is the other way, because we would say we would use inches. And now how long is that line going to be? Okay, it's going to be 120, meaning an inch and 20% more. I have there, and I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So I have it in 8, so it's basically there. So that would be the vector is going to be here, the angle, and that angle is going to be 315. Or if you want to take this angle, this is negative 45 degrees. And the this is 120 newtons, which is the magnitude. Now, how do we do the resultant? Simple. Here we go. We start. Now, to recap, I go from the origin, I draw my first vector, then I make the last point of the arrow my origin again. I draw my second vector. What if I had many? The same thing. The same thing will happen. So I go here and I'm going to draw a line from the origin now to get the resultant to the last point. I'm going to use a different color now. And I'm going to use the resultant. I know the girls in my classes, they prefer pink, so I'm going to use pink for this one. So I'm going to measure from the beginning here, yeah, that line. This is going to be a resultant force, R, and R is going to be what? I'm going to measure it here, and it's like 2 inches and a little bit more, let's say in 205 newtons. Got it? What angle do I have? Let's check. I have 10, 20, 25, around 25. So this angle is going to 25 degrees. So basically, the resultant force, this one will be resultant vector. In this case, it's a force because it's in newtons. Resultant force, or R, is going to be equal to 205 newtons, and my angle is going to be 25 degrees. Now, what is the result for this one? If you remember, I'm going to just jump and show you the other from the other video. We had a resultant of 204.88. Oh, so basically the same thing, right? And we have an angle of 25.5. So there you go. We have the same result and the analytical way. This is the other one. So we got kind of the same one here, the magnitude, and we have the same angle here. So that is it, boys and girls. The analytical way, the graphical way. Don't get confused. What is the difference? The graphical uses a graph, a drawing. This one uses, as you can see, trigonometry and some other stuff. In this one, we have to take the components of in x and y, add them up, and then just calculate the resultant force and the angle. And in this one, you just start drawing from the center, then draw the Cartesian plane, draw the second vector. If you have many, well, you keep doing that until the end. You want to make the addition, you start from the origin to the last point, and that will be basically it. If you have any questions, please do write me. You know my email. And well, thank you very much. This has been a presentation by your teacher, Mr. Rod. Bye.